Good morning, everybody, and once again, welcome back to the channel. In this particular video, I would love to talk about faster iceberg merges. Of course, yes. Who does not like speed? We want everything to be fast and performant. So, how do we achieve that? Right. In this video, we'll take a look at a step-by-step approach. What I will do in this video is I'm gonna give you my compiled summary. I spent close to about 4+ hours yesterday, analyzing iceberg merges, seeing the push down predicates, etc. So what I'm gonna do is I'm gonna give you a compiled version of my learning in this video. So without wasting any further time, let's get started. Okay. All right. So for the demo, before I explain, we have two tables nearly, right? One is your target table where we have some mock data, and one table is where we have some updates that are there, right? I want to join and I'm going to do some merges, and I want to show you the differences in that. Okay. So hopefully on a broader level it makes sense. Okay. So two tables I have, and the goal is to read from this particular table, the stage table, and then update into my target table. What I want to show you here in this video is a step-by-step approach, on incremental approach on how we can improve the performance, right? All right, so let's get started, man. Okay, so I have already done it. So I have a bunch of Spark UI. I'm gonna show you a summary of what each one does. Okay, so let's go to the first merge query over here. Okay. Very simple. Merge into this is the target table that I'm doing merge into, and if and you can see ID, right? The join condition is on ID. And before that, I just want to show you the table, how it is partitioned by. Both the table is partitioned by year. Okay, both the table is partitioned by year. Okay. Now let's take a look at the merge, right? So this is my first merge query. I'm doing a merge on ID in this case. So again, if you go to Spark UI, right? Important item that you will see if I do a filter over here. Look here, if you can probably see my screen, there is no push down predicates, right? Even though in the incoming data, right, incoming data is only for year 2025, and the target table has a lot of years, right? So it's not able to do a push down predicate. So how do I make it better, right? That's the question. So the first version right here, what you see is just simple ID, and then I know if it's matched, then I update. If it doesn't match, I insert, right? This is great, works fine. How can I make it better? Let's take a look at the second condition, push down. The only thing that we add is that target.year is equal to 2025, and this makes a huge difference. So let me show you by just adding this and a condition. Look at let me show you the first one first. Give me one sec. I just need to search for output. Okay, so look at the output rows over here. If you can see, 30,000 is the output rows. By just adding that one condition, right? By just adding this target.year is equal to 2025, by hinting that, okay, we are able to do a push down. We are able to pass the filter, and look at here the output rows, 15,000 halved, right? And you can verify that from details. And if I here you can see, right, over here in the filter you can see filter is equal to year is not null, year is equal to 2025. So we are able to pass down that push down predicate, right? See, so far so good, right? So the only change that we have done in the merge is basically adding this particular push down predicate. So the first one was just on ID. The second one we said, okay, you know what? Let me see. I can filter. I can pass. I can do a push down, right? Can we make it better? And the answer is absolutely yes. All right. Let's take a look at the third version. Now the third version. Okay. So before I go to the third version, I have made a video on SPJ join. Right now, both the tables, as you know, this table over here is partitioned by year. This table over here is also partitioned by year. So in theory, I can directly do a join on the partition and write, and then I can also pass down the push down predicate. And that is exactly what the SPJ join does. So also important thing you will see in the first one, again, just giving you a high level, right? Let me see, where is that? So you see this exchange block. So the first merge query, let me go a little bit slow here. Okay. The first merge query that we had, where it's just straight up ID, right? You have an exchange block. which means the data is shuffled over here across the nodes, right? And then you also see sorting, and it uses a sort merge join, right? Right. In the second version, where we did a push down, of course you will see an exchange block, sorting, etc. What's different is basically the push down filters, right? Now the third one that I have, that we're about to see, SPJ join, yeah. So this one right here, the only difference you see is this block right here. This makes all the difference. This is the partition column. Both the tables are partitioned by year. So in the merge, if you want to use an SPJ join, you have to specify this, okay? So target.year and src.year. Now look what happens. It will amaze you, right? Okay, so let me see. Yeah, so does a sort merge join? Observe one thing very careful if you are. There is no exchange block. So data is not shuffled. It is directly doing a join on the partition. So, so no exchange block, which means the SPJ join is working fine, right? As you can see. And after doing the sort merge join, the data is merged. Then again, it is there's a shuffle, and then basically sort, and then basically return to that. Can we do something better, right? So okay, in this version, what we essentially did is we got rid of the exchange block, the shuffling that was happening. We got rid of that. Great. And then basically we are able to do the join, and then after the join, after the rows are merged, again there's some exchange, sort, and then data is returned into the target table. Can we do something better here? Yes. There's one more thing we can do better. And again, this is more like an experimentation, like feel free to like play with that. So on Iceberg, I can set a property called write.spot.fanout.enable to false, right? So it was false, and then I'm gonna set this one over here to none. So spark.sql.iceberg.distribution mode is set to none. I believe, I may be wrong here. I believe the default is set to hash. I'm not sure. I need to check. But if you do that, right, and if you execute the same merge query, look at the on condition. We have the ID, we have the push down predicate, right? Predicate, right? And this is the condition for the SPJ join, because both the table are partitioned by year. Now, what you will surprisingly see in the last one. So see, again, same thing, right? We have this no exchange block to note over here after the sort merge join merge. Look, there is no exchange block at the final part. Look here, this one. So before that, after merge, right, exchange, sorting, and then return, right? Write the delta, right? Merge, there's the stage block, and then write the delta. No exchange block. So again, I have compiled, of course, my all the learning of 4 to 5 plus hours that I was spending to like see all these minute details in a short video, and I hope this is informative. Surprisingly, one more thing that I wanted to add, maybe I want to understand more is like when I was adding the year predicate, right? Why is in the merge, why is it not being pushed down? So that's something I would maybe want to figure it out for the later part. But I hope you enjoyed this particular video. What I'll do is I'll also leave the code snippet. So I have a nice Jupyter notebook that I developed for my personal understanding, right? So I'll leave that as well. Another one that I want to leave, I think this is where I found all the details, and it's pretty well written, to be honest. Over here, optimizing Iceberg merge has done a fantastic job. Again, step by step, again, he explains all the item in detail. So here you can see the default is sort merge join. He then colors out this sort block and the exchange block as a red color. So you could basically remove that using, of course, the shuffle hash join. So if you keep scrolling down, he shows clearly, see, there is no filter or no push down filter over here. After that, if you keep scrolling, if you read the entire blog and if you have patience and if you go through it, really it's very informative blog. The final version, you have SPJ join, sort block is eliminated, there's a push down filter, and the exchange block at the final part is also eliminated. Again, fairly interesting blog is all I would say. So, give it a read if you want. So that's all that's all I have for the video. I hope you have enjoyed the insight. Again, it took me a while to do this, observe these details. But it's fun. It's definitely worth it. It definitely has made me more confident. I understand the inner workings of it at this point. So that's all I have for the video. Keep smiling, keep programming, and if you have any question, list them in the comment window. And until then, I'll see you in the next video.